Hello children, welcome to Yamuna's physics classes. So in this video we are going to discuss about a half wave rectifier of the lesson semiconductor devices, section 14.7. Information: we have studied half wave rectifier in the previous video. So the link of the video will be given in the description. Please watch the video, only then come to listen to this video. Means lot many things regarding rectifier we have mentioned there. Here we have only saying what is the major difference between half wave and rectifier, full wave rectifier. So we are just adding one or two things to half wave rectifier. That's why I told you, go to the first video, half wave rectifier, watch it and then come. Okay, let us start. So in half wave rectifier, what we had is, we had only a single diode. We had only a single diode in half wave rectifier. Here we are using two diodes. You can have even more diodes, but here we are using two diodes. And the position of the load is also modified. In one directional or half wave rectifier, we had the load placed here. Placed here means it was in series in the circuit. The load was placed in series manner in the circuit. But here you can see we are placing the two diodes. In between the two diodes, the load is placed in a parallel format. Meaning the two common terminals of the diode D1 and D2 is this, and that particular diode is connected to one end of the load. Also, the other point is placed over the center tap. Center tap may be a new word for you. Transformer, this is the primary, this is the secondary. We know the number of windings is proportional to the voltage. Higher the number of windings, more the voltage. Lesser the number of windings, less voltage. So from this secondary of the transformer, you are taking an output or a line from just half of the number of windings. That is center tap. You are tapping the voltage. Tapping means taking out the voltage exactly from the center of the windings. So we will say center tap transformer. So you are using a third output. Usually we have only two outputs for a transformer. Here you are taking additionally a third one from the center of the secondary windings. Hence the term center tap transformer. So that particular point, center tap, at the one end of the load, and the common terminals from the diodes D1 and D2 to the other end of the load. So this is the only modification what you have done here, other than the half wave rectifier. And also you have using one more diode. In half wave rectifier you have only one diode. Here you have two diodes with load in a different position. Clear? Now what is the difference between half wave and half wave and full wave is that in half wave rectifier you know that if this is the input AC wave, the output will be you had only one diode, that is D2. You had only the waves D2, D2, so on. But here when you are adding D1, the remaining half cycle, the negative half cycles were not rectified using previous half wave rectifier. But here you can see during negative half cycles, D2 remains silent and D1 activates. Means you are getting output for the negative half cycles also. So that is how D1 helps to rectify both positive and negative half cycles. So in detail, what is happening? It's very clear what's the principle. A diode conducts current only during forward biasing. What do you mean by forward biasing? This is the positive terminal, this is the negative terminal, and you can see that the arrow mark explicitly shows current is flowing along the direction of arrow. So if this is a diode, current flows through the diode only in this particular direction. Similarly, if this is a diode, current flows through it only in this particular direction. And when does it flow? Only during forward bias. And what is forward biased? If the negative terminal is connected to negative, if the positive is connected to positive, at the time it is known as forward. If the negative is connected to positive and reverse, it is known as reverse biased. So let us see what is happening when a positive half cycle is coming. Suppose a positive half cycle is coming to this diode. What will happen? At the time, when the positive half cycle is arriving, suppose this part of D1 is positive and this part of D2 is negative. For sure, if this is positive, the other end of this secondary will be negative. So if this is positive, positive connected to negative, negative connected to negative. So who is forward biased? D2. Who is reverse biased? D1. So during forward bias, who will conduct? D2. So this forward pulse or positive half cycle is passed, or that is being allowed to pass through by whom? D2. So D2 conducts current during every positive half cycles. At the time, D1 will be reverse biased, silent. I have told about the traffic island. Forward bias means green signal. Reverse bias means red signal. No flow of current. So during positive half cycle, D2 is getting activated. Now what about the reverse negative half cycles? What do you mean by negative half cycle? During negative half cycle, this terminal will be negative and this terminal will be positive. Meaning, during negative half cycle, D1 is forward biased, D2 is reverse biased. So D1 allows current to pass through during negative half cycle while D2 is resting. So they are doing their work alternatively. When D2 is activated or forward, D1 will be reversed. When D1 will be forward biased, D2 will be reversed. So throughout the entire cycle, positive as well as negative half cycles, we are getting uniformly output. Hence the word full wave rectifier. So this is a full wave, with a positive and a negative half cycle. In both the half cycles, we are getting pulsating DC. Pulsating means what? A DC means current in a particular direction. You can see for this diode working, the current through the load is in this direction. You can watch the arrow, it is going well through this. And for the negative half cycle, again the current is going through this. Means for the entire cycle, through the load, inside the load, within the load, you can see that current is going from left to right in this direction only. So unidirectional current, one directional current you are getting throughout the load. And the output of the load is drawn as this. That is pulsating DC, a device which converts AC to pulsating DC. Now to remove the pulsating DC or to remove the pulses out of this DC or the rectified DC, we need capacitors and inductors. We have studied about capacitors and inductors in the lesson AC. So if you could connect a capacitor or inductor parallel to the load, you connect this parallel to the load, then the ripples, this is known as ripples. On the surface of the water, you will say ripples. That amount of ripples in this DC can be minimized to a good extent using capacitor and inductor. So that is known as filter circuits, which is filtering the pulsating elements present in this DC. Okay. Now, so what is the principle? PN junction conduct heavily in forward biased and will not conduct in the reverse biased. Now what is the working? We have clearly mentioned during positive half cycle, current flows through the diode D2 Meanwhile, D1 is rest. Whereas the diode D1 will be conducting in the negative half cycle. During negative half cycle, D1 is activated and D2 reverse biased rest. So the rectified output is for the full input. Throughout the input, that is for both positive and negative half cycle, we are getting a unidirectional current. Only thing, it is a pulsating DC. Clear? Hence the efficiency is doubled. Why? If we are charging with the adapter in the previous using half-wave rectifier, you know, for each half cycle, negative half cycle, it is going to rest. Charging happens only during positive half cycle. But here you can see charging happens for both positive as well as negative half cycle. So the efficiency is doubled. So we use full wave rectifiers instead of half wave rectifiers in an adapter. Okay, so hope it is clear. If you have any doubts, please post in the comment box. So you can just take a screenshot, write down, learn it out. Thank you for listening.